The anatomy of a spatial tear. What if the greatest shortcut in the cosmos has been hiding inside our mathematics for over a century, waiting for reality to catch up with our equations? Think about the sheer scale of the loneliness out here. You are floating in the absolute silence of interstellar space, positioned just outside the outer rim of our galaxy. Below your ship, the Milky Way stretches across the dark as a massive, rotating disk of pale starlight, holding billions of suns in a slow, gravitational dance. The vacuum around you is vast, undisturbed, and freezing. But then, the coordinates directly ahead of you begin to bend. A cluster of stars starts to warp. The light from those distant suns stretches into curved, liquid lines, distorting around a circular patch of space. This is not a black hole absorbing light. It is something else. It is a phenomenon known as gravitational lensing, where the geometry of space itself is twisted out of shape. As you watch from the flight deck, the distortion stabilizes. A circular gateway opens. Inside this boundary, you are no longer looking at the Milky Way. Through this strange opening, you can clearly see a distant crimson nebula that exists millions of light years away. It belongs to a completely separate region of the universe. The space inside that shimmering circle feels entirely disconnected from the cold vacuum you are currently resting in. You are staring at a localized tear in the geometry of space. A shortcut built out of nothing but warped space. Your ship inches closer. The thrusters fire in short, silent bursts. The ring of distorted starlight around the phenomenon grows wider, casting a pale glow across your control panels. The sensors on your hull show no solid surface ahead, only a profound gravitational gradient that seems to rewrite the local laws of distance. For generations, humanity viewed these immense distances between stars as an absolute barrier. Early astronomy treated space as a rigid, empty container, a static stage where planets and stars move, but the stage itself remains completely fixed and unchangeable. Under this old framework, the gulfs between solar systems meant absolute isolation. Even traveling at the speed of light, it would take years to reach our closest stellar neighbors and eons to cross to another galaxy. The universe appeared to be a collection of isolated cosmic islands, separated by an uncrossable vacuum. However, modern physics paints a completely different picture. Space is not empty, and it is not a passive backdrop. It is a dynamic medium that can be stretched, compressed, and curved by the presence of mass and energy. Go back to 1915. Albert Einstein publishes his general theory of relativity and fundamentally changes our understanding of reality. He demonstrated that gravity is not an invisible pulling force between objects, but rather the structural curvature of space-time itself. A massive object, like a star or a planet, presses into the fabric of space, creating a geometric depression. When a smaller object or a ray of light moves past that star, it follows the curve of the depression. What we experience as a gravitational pull is simply an object navigating the warped geometry of space. The ship's proximity alerts beep softly in the quiet cabin. The numbers on the telemetry screens are shifting rapidly. The crimson nebula inside the anomaly is becoming sharper, its gas clouds swirling in real time, completely unsynchronized with the stars outside your viewport. You are hovering on the edge of a mathematical frontier. If we follow Einstein's field equations to their absolute limits, a fascinating theoretical possibility emerges. If mass can warp space, time to create a localized well, can that curvature become so extreme that it punches through the fabric entirely? If two separate regions of the universe both create these extreme distortions, can those distortions connect in the middle, forming a continuous path through the dark? This theoretical pathway is what we call a wormhole, known in the scientific community as an Einstein-Rosen bridge. to understand what a wormhole actually represents, it helps to move away from standard textbook analogies and look at the universe as a multi-layered structure. Imagine our three-dimensional universe exists on the surface of a vast, curved space. To travel from one point on this surface to another, you would traditionally have to move across the entire expanse, covering immense distances through the standard vacuum. This linear journey is strictly bound by the cosmic speed limit, the speed of light. A wormhole, however, represents a theoretical shortcut that cuts directly through the higher dimensional space beneath the surface. It links the two distant points through a localized tunnel. By traveling through this conduit, you are not actually moving faster than light through space. You are not violating the laws of relativity. Instead, you are simply taking a shorter physical path because the geometry of the universe has been altered. The millions of light years of empty space that lay between the 2 points are bypassed entirely. The ship moves another 100 meters forward. The gravitational field gently grips the hull, not with a violent pull, but with a steady, enveloping pressure. The boundary of the anomaly now fills half your horizon. You can see the exact line where the stars of our galaxy blend into the light of the alternate universe inside. It is important to understand that in our three-dimensional reality, the entrance to a wormhole would not look like a flat hole or a dark tunnel. Because a wormhole curves space equally from all directions, many theoretical models suggest that if a traversable wormhole existed, its mouth would appear approximately spherical. It would manifest as a flawless, shimmering bubble suspended in the vacuum of space. If a starship were to approach this sphere, the boundary, referred to as the mouth of the wormhole, would not present a physical barrier. It is a mathematical horizon, a transition zone where the physics of standard space would seamlessly connect to the interior of the tunnel. The starlight from our own universe would warp around the outside of the bubble, creating a highly distorted, glowing ring of light. At the same time, the interior of the sphere would show a direct, real-time visual projection of the destination galaxy. The sphere acts as a literal cosmic window, floating in the dark, marking the boundary of the shortcut. As you observe this theoretical structure, our traditional understanding of time also begins to shift. A wormhole is not merely a bridge across physical distance. General relativity suggests it is also a connection between different states of time. Because time moves at different rates depending on speed and gravity, the two mouths of a wormhole do not have to be synchronized. The destination inside the sphere could exist in a completely different era, meaning that stepping through the boundary involves leaving the standard, linear progression of human history behind. But we must ground ourselves in reality. While the existence of wormholes is fully permitted by Einstein's equations, they remain entirely theoretical. We have not yet detected a real wormhole in the observable universe. The immense forces required to create, stabilize, and hold open such a structure demand conditions that challenge our current cowledge of quantum mechanics. The math works perfectly on paper, but the physical reality of building or finding one requires ingredients that physics is still trying to define. Now, the destination is no longer just a window. It is your immediate future. The ship approaches the mathematical horizon of the sphere. The distorted ring of starlight around the mouth expands, occupying your entire field of view. The familiar stars of our galaxy begin to compress behind you into a single, receding point of light, while the alien sky inside the sphere rushes forward to consume the dark. The transition across the boundary is perfectly seamless. No turbulence, no sudden shifts in weight. The ship glides over the edge, moving away from the known coordinates of our solar system and entering a silent, stable corridor carved directly out of the architecture of the cosmos. You have left the grid of home behind. The true journey has just begun. Different types of wormholes. What if nature doesn't build just one kind of gateway? If you look closely at the equations, you realize that space-time can break apart in more than one way, leaving completely different types of structural scars across the dark vacuum. Outside the glass viewport, the absolute silence of the voyage returns, but the visual landscape begins to alter. The distant, warped starlight doesn't just twist anymore, it begins to pulsate, aligning into geometric patterns that hint at the complex cosmic architecture ahead. You aren't just moving through space, you are navigating a gallery of mathematical blueprints. To understand the first structural model of a spatial tunnel, we look back to 1916. While serving on the front lines of the First World War, German physicist Karl Schwarzschild extracted the first exact solution to Einstein's field equations. His calculations described a point of infinite density, a static black hole where gravity was absolute. Yet, deep within Schwarzschild's mathematics lay an unexpected symmetry. The equations didn't just project a bottomless pit that swallowed matter, they predicted a mirror image on the other side of existence. This framework was later refined by Albert Einstein and Nathan Rosen, creating the concept of the Einstein-Rosen bridge. Imagine a channel shaped like a massive three-dimensional hourglass. The wide top section represents our familiar universe, which slowly compresses down into a narrow, microscopic throat. In the purest form of the math, this throat does not terminate in a dead end. It opens back up, widening out into an entirely separate region of space-time, or perhaps an alternate universe altogether. But as you look out into the quiet corridor, the space ahead suddenly flashes with a sharp, violent distortion. The geometry pinches shut. This is the fatal reality of the Einstein-Rosen bridge. It is entirely untraversable. In real physics, this classical model is fundamentally unstable. It exists only for a theoretical microsecond. The moment it forms, the immense gravitational pull causes the neck of the tunnel to choke. The throat snaps shut so fast that not even a single particle of light could cross from the entrance to the exit. If any physical matter enters the bridge, the mass of that object instantly triggers a total collapse, pinching the tunnel into isolated, dead-end black holes. For decades, these bridges remained beautiful mathematical anomalies, completely closed to travel. The tension in the space around you dissolves as your ship drifts away from the unstable Schwarzschild coordinates, sliding into a much more fluid, uniform channel. The crushing gravity drops back to a baseline hum. You are entering the domain of a traversable wormhole. In 1963, a mathematician named Roy Kerr discovered a new solution to Einstein's equations by adding a highly realistic factor, rotation. Real stars spin. When a massive star collapses, its rapid rotation changes the internal landscape of gravity. The immense centrifugal force fights against the inward pull, preventing matter from crushing into a single point. Instead, highly theoretical mathematical solutions hint that the singularity might stretch into a rotating ring of infinite density. Because it is a ring, some models suggest a fascinating path, a trajectory that passes directly through the empty center of the ring, bypassing the destructive mass entirely and exiting into another region of the cosmos. The landscape outside your window smoothens once more, settling into a pristine, circular vault. The violent dynamics of the spinning ring give way to the calmest highway ever conceived, the Morris-Thorne wormhole. In the late 1980s, physicists Kip Thorne and Michael Morris decided to reverse the entire approach to wormhole physics. Instead of looking at violent, collapsing black holes, they engineered a theoretical space-time geometry designed specifically to be safe for human travel. They mapped out a conduit free from event horizons, allowing a traveler to turn back at any moment. They calculated a path where the structural stress inside the throat remained completely gentle, matching the baseline gravity of Earth so that the human body would experience zero physical distortion. But this ideal canal that demands a price. To prevent the walls from instantly caving in under their own massive weight, the equations require the presence of a negative energy pressure, a force that acts entirely opposite to standard gravity, propping the throat open against the crushing collapse of reality. The corridor ahead begins to widen, revealing a vast, open expanse of dark space. The theoretical variations, from the flashing, unstable bridges of Einstein and Rosen to the spinning rings of Kerr and the stabilized paths of Morris and Thorne, prove that the architecture of our universe is incredibly flexible. The shapes are mapped. The blueprints are clear. But as you float further into the dark, you are no longer just looking at the geometry. You are about to feel the physical forces that govern the transit through the unknown. Can humans travel through one? The pristine, uniform corridor of the Morris-Thorne vault holds your vessel in absolute stillness. Outside the viewport, the violent distortions of the home galaxy have vanished, replaced by a smooth, architectural conduit of pale, iridescent light. Space here does not feel empty. It feels structured, tightly controlled, and perfectly silent. The journey seems completely effortless. Yet, as the ship drifts deeper into this spatial throat, the true physical reality of the environment begins to press against the narrative of smooth transit. Mathematical models permit these channels to exist, but crossing them introduces a completely different scale of physics. To understand the first physical barrier of transit, we must look away from the giant spheres visible to a starship and look down into the microscopic subatomic fabric of the universe. If you zoom in past the scale of atoms, past electrons, and down to the absolute smallest metric of distance, the Planck length, space-time ceases to be smooth. It becomes a violent, boiling sea of quantum fluctuations known as the quantum foam. At this microscopic layer, the energy of the vacuum is so intense that tiny subatomic tears in space open and snap shut every trillionth of a millisecond. These are naturally occurring wormholes. They are real, but they are smaller than a single particle of light. For a macroscopic entity, like a human being or a starship, this scale barrier represents an absolute wall. To be of any use for travel, these quantum bubbles must be artificially inflated and stabilized using immense amounts of energy. A feat that requires manipulating fields far beyond our current engineering capabilities. The silence outside your window deepens, but a subtle change occurs in the light field. The uniform hues of the vault begin to shift, losing their symmetry. A localized pressure manifests against the outer skin of the craft, felt not as a sudden jolt, but as a heavy, dragging weight. This introduces the second fundamental hazard of transit, the trigger problem. Theoretical frameworks indicate that a wormhole throat is an incredibly sensitive gravitational balance. It is fundamentally reactive to anything that enters its field. The moment a physical object, whether it is a massive exploration vessel or a single stray photon of light, crosses the mouth, the mass and energy of that object disturb the delicate geometry holding the tunnel open. The introduction of external mass acts like a gravitational trigger. The space-time walls respond to this disturbance by instantly pulling inward. Without a constant, mathematically precise counterpressure pushing outward, the throat will undergo an immediate structural cave-in, snapping the conduit apart and trapping the traveler inside a localized singularity. The ship continues its forward glide, but the external environment is no longer uniform. The smooth walls of the corridor begin to elongate, stretching forward into long, thin columns of color that seem to narrow toward a distant point ahead. You are entering a zone of extreme gravitational gradients. When an object approaches a massive gravitational source, it experiences what physics defines as tidal forces. This is the difference in gravitational pull felt across the physical dimensions of an object. If you were to descend into a narrow, non-idealized wormhole throat feet, first, The geometry of space dictates that the gravity pulling on your feet would be significantly stronger than the gravity pulling on your head, simply because your feet are a few quarters of a meter closer to the central point of attraction. This differential pull scales up exponentially within a sharp spatial distortion. The universe begins to execute a process of extreme material transformation, known scientifically as spaghettification. As the gravitational gradient steepens, the forces do not merely pull the ship forward, they pull the front of the craft faster than the rear, stretching the metal hull like fluid glass. Simultaneously, the lateral coordinates compress inward, squeezing the sides of the vessel toward a central axis. In a non-stabilized passage, any complex structure, whether an alloy frame or a biological body, is ruthlessly elongated into a thin stream of constituent atoms, completely dismantled by the sheer geometry of the gradient. But inside this specific corridor, the structural collapse does not occur. The expansion is checked by the negative energy pressure woven into the vault, keeping the tidal forces below the threshold of physical destruction. Yet, another invisible hazard is steadily accumulating within the throat. The light ahead of the vessel is changing color, shifting from a calm amber into a piercing, brilliant sapphire. This is the manifestation of the blue shift effect. Because a wormhole is a shortcut connecting two completely different sectors of the cosmos, light from both ends of the universe enters the tunnel simultaneously. As these photons fall down the steep gravitational well of the throat, they gain immense amounts of energy. Their wavelengths are compressed. Gentle, visible starlight falling into the mouth is squeezed into high-frequency spectrums, transforming into lethal streams of X-rays and gamma radiation. Inside the throat, this energy has nowhere to go. It becomes trapped, circulating back and forth through the conduit, building up a permanent radiation furnace that bombards anything attempting to cross the central metric. A traveler cannot simply fly through open space. They must navigate a corridor that naturally concentrates the high-frequency energy of two distinct universes into a single point. The sapphire light outside the viewport slowly stabilizes, its intensity held in check by the specialized geometry of the path. The ship holds its course, suspended in the center of the vault, moving past the friction of the scale barrier, the threat of the cave-in, and the invisible wash of compressed radiation. The physical hazards of the throat are dropping behind the vessel, leaving you intact, unchanged, and perfectly stable. The corridor is opening up into the deeper chambers of the shortcut. The structural test of the material world has been cleared, but the rules of the destination are already beginning to rewrite themselves. The coordinates of space have been managed, but the coordinates of time are about to unfold. Exotic matter. The intense sapphire glow of the radiation furnace slowly fades into the rear view, leaving your vessel suspended in a profound, ink-black quiet. The physical strain of the gravitational gradients has loosened its grip on the hull. You are floating through a section of the tunnel that feels remarkably stable, almost serene. Yet, looking out into this dark vault, a deeper question emerges, one that forces us to look directly at the heavy architectural foundations of space-time itself. What is actually preventing this entire corridor from violently collapsing in on itself? To understand how this pathway remains open, we have to look at the strict, unyielding laws of standard gravity. In our everyday lives, and throughout the observable universe, gravity is an attractive force. Every piece of matter we have ever touched, measured, or observed follows this singular rule. A planet, a star, a human body, or a microscopic speck of dust all possess positive mass. Because they have positive mass, they draw other objects toward them. When you pack enough of this normal matter into a single region of space, the fabric of the universe curves inward, pulling everything down into a central well. Left to its own devices, space-time is fundamentally allergic to tunnels. If you attempt to dig a shortcut through the cosmos using normal mass, the gravity generated by the tunnel itself acts as an immediate self-destruct mechanism. The walls are drawn toward the center with absolute force, causing the neck to choke and snap in a fraction of a millisecond. Holding such a structure open demands a profound counterweight. The conduit requires an engineered environment that defies the gravitational behavior of every known element in the periodic table. Theoretical physics designates this required substance as exotic matter. It is critical to separate this concept from the other mysterious elements discussed in modern astronomy. Exotic matter is not dark matter, which is an invisible substance whose immense positive gravity holds galaxies together. It is also not antimatter, which consists of real particles with subatomic charges reversed, falling downward under the influence of standard gravity, just like ordinary hydrogen or iron. Rather, in many traversable wormhole models, the required exotic matter possesses regions of negative energy density and violates the classical energy conditions of general relativity. Whether this also corresponds to macroscopic negative mass remains an open question within modern astrophysics. To grasp the true strangeness of this property, imagine the localized dynamics of a system that violates the classical null energy condition. If you take a block of normal matter and push it forward, it accelerates away from you, moving in the direction of the force. But under specific interpretations of negative mass equations, the interaction turns inverse and highly volatile. Simulating these properties in a gravitational field suggests complex runaway effects where the standard rules of kinetic attraction dissolve. Propping the throat open against the crushing collapse of reality requires exactly this property of gravitational repulsion. Instead of pulling space together, localized zones of negative energy density generate a powerful outward pressure. They act as a set of invisible structural arches that physically support the spatial coordinates, pushing the walls of the tunnel away from the center. This counteracts the immense inward pull of the surrounding space-time fabric, neutralizing the natural tendency of the throat to cave in. Without this continuous cosmological anchor, the stable corridor your ship is currently navigating could not exist for a single second. For decades, many prominent physicists dismissed negative energy as a pure mathematical fiction, a neat trick with negative signs on a chalkboard that had no grounding in the physical world. The universe, they argued, simply did not allow for such a violation of thermodynamic rules. However, the development of quantum field theory completely altered this perspective. When we observe the vacuum of space at a fundamental level, we discover that empty space is never truly empty. It is a highly dynamic environment, constantly fluctuating with virtual particles that pop into existence and annihilate each other in fractions of a second. In 1948, a Dutch physicist named Hendrik Casimir discovered that this quantum activity could be manipulated to alter local energy densities. This phenomenon is known as the Casimir effect. Imagine two perfectly flat, highly polished metal plates placed inside a total vacuum, completely isolated from all external radiation and matter. You bring these two plates incredibly close together, separating them by a distance smaller than a microscopic fraction of a millimeter. In the macroscopic world, nothing should happen. The plates should remain perfectly still. But at the quantum scale, the narrow gap between the plates creates a strict boundary condition. The space between the plates is simply too tight to accommodate long quantum waves. Only short, high-frequency waves can exist inside the gap. Meanwhile, outside the plates, quantum waves of all sizes and lengths bounce around freely. Because there are significantly more virtual particles generating pressure on the outside of the plates than on the inside, a measurable force pushes the two plates together. More importantly, the Casimir effect demonstrates that quantum field theory permits regions where the local energy density is lower than the surrounding vacuum. effectively behaving as a localized source of negative energy. Yet, as your vessel glides further through the dark expanse of the vault, the scale barrier of this phenomenon becomes glaringly obvious. The negative energy generated in our laboratories through the Casimir effect is microscopic, barely enough to move 2 sheets of metal a few nanometers. Quantifying the total energy budget for a stable shortcut reveals immense challenges. Many early mathematical models required enormous amounts of negative energy to maintain transit channels. However, subsequent theoretical adjustments suggest that specific, clever geometries might drastically reduce the necessary amount of exotic matter, localized only to ultra-thin layers inside the throat. Modern physics does not yet know if the universe allows for the accumulation and stabilization of negative energy fields on a gargantuan, macroscopic scale. Nature may possess hidden quantum restrictions that prevent large-scale violations of energy conditions, effectively keeping these cosmic doorways locked. The silent dark of the corridor remains unbroken. The outward pressure generated by the theoretical architecture holds the space around the hull perfectly uniform, allowing your ship to pass through the zone where quantum mechanics and general relativity hang in a delicate, artificial balance. The structural metrics of the shortcut have been stabilized, but the reality of the calendar is about to dissolve. A heavy, temporal shifting is waiting just beyond the shadow of the current corridor. The geometry has held firm. Now, the ticking of the clock must face its own curvature, time, dilation. Nothing outside the viewports suggests movement, yet time inside the vessel refuses to keep pace with the universe beyond. The digits on the structural interface are not frozen, nor have the master systems glitched. Instead, the intervals between pulses are lengthening, tracking a slow, weighted signature that operates entirely outside the synchronization of the home world. The deep structural link between position and duration is laying itself bare. You are floating through the physical consequence of time dilation. To clarify why an alteration in spatial geometry rewrites the calendar, the old assumption of a universal clock must be cast aside. Contemporary physics recognizes time as an elastic coordination, locked directly to the local architecture of space. Altering an object's velocity or shifting its proximity to a concentration of mass systematically shifts its rate of aging. Consider the behavior of high-precision atomic clocks placed within different kinetic frameworks. If one sensor remains anchored to a static baseline, while a secondary unit is accelerated to relativistic velocities through the vacuum, the underlying geometry of the continuum shifts. To a stationary observer, the ticking mechanism of the moving clock appears to slow down dramatically. The physical system inside the moving framework experiences no internal disruption. Biological processes and mechanical frequencies function normally. Yet, upon deceleration and return, the traveling system emerges noticeably younger than the baseline that stayed behind. Operating this dynamic is not confined to conceptual thought experiments. The calibration of modern global positioning satellites relies entirely on managing this variance. Orbiting thousands of miles above the planet, these digital arrays travel at high operational speeds relative to the ground. This velocity causes their internal tracking systems to lose roughly 7 microseconds every day compared to sensors on the surface. Simultaneously, their high-altitude positioning places them in a slightly weaker gravitational field, causing them to tick faster by about 45 microseconds a day. Without continuous, calculated adjustments programmed directly into the operational software to reconcile these opposing relativistic balances, satellite navigation systems would drift by kilometers within a single day, rendering tracking grids completely useless. The space surrounding your vessel remains perfectly transparent, yet the stars beyond the horizon are no longer sharp points of light. They have begun to smear into soft, circular tracks, drawing bright rings around the quiet void. This visual shift confirms that your local clock is expanding. The interval between your own thoughts remains seamless, but the relationship between your ship and the outer universe has dissolved its standard contract. A separate, deeper variation is asserting its influence, the compression of time via mass. Mass deforms spatial coordinates to produce the geometric effect we experience as gravity, but it simultaneously alters the progression of time itself. Descending into a gravitational well compresses the local duration metric, slowing down the clock relative to an observer positioned in flat space. High-altitude flight experiments and modern atomic sensors placed at varying planetary elevations confirm that clocks situated closer to the heavy core of a planet tick marginally slower than those resting at higher altitudes. Within the steep coordinates of a deep spatial shortcut, or the vicinity of a massive stellar remnant, this structural compression scales up significantly. Remaining suspended within an intense gravitational gradient exposes an object to a massive vertical drop in the geometry of duration. For a system operating near that dense boundary, a single elapsed hour could correspond to the passage of months or years across the empty, unwarped sectors of outer space. Observing the surrounding local space from the viewport would reveal nearby stellar systems shifting through their developmental paths with unnerving speed. Their cycles condensing into a rapid sequence of light variations, while your internal experience remains perfectly constant. Theoretical frameworks indicate that if traversable wormholes exist, their two mouths could become a direct conduit between completely different eras. The primary entrance might be positioned in an empty cosmic void where time advances at a standard, uncompressed rate. The secondary exit could be anchored deep within the gravity well of a dense stellar system where the temporal flow is heavily retarded. Crossing the mathematical horizon under this configuration would simultaneously shift an object's position on the spatial map and its placement on the cosmic timeline. As the vessel drifts further down the silent axis of the vault, you observe the slow, external transformation of light fields. The distant glare of the home galaxy, now nothing more than a faint halo behind the mouth of the shortcut, appears to be locked in deep freeze. Its rotation has slowed to an absolute crawl, frozen by the profound temporal gulf that now separates your craft from the coordinates of your birth. The universe behind you is aging at a different speed, leaving you suspended in a neutral, isolated interval where the concepts of yesterday and tomorrow lose their structural meaning. The dark passage ahead widens without warning, the pale columns of light fading out into an immense, shadow-filled vault. The geometric lines do not loop or twist, they simply stop, opening up into a massive chamber of absolute stillness. The mechanical tracking arrays register no gravitational shifts, no radiation spikes, and no temporal drift. The interior systems fall into a rhythm of total equilibrium, matching the complete, silent suspension of the cosmic landscape outside. The environment has settled into a state of total unmoving neutrality. Space is wide, dark, and perfectly quiet. The heavy synchronization of the past has faded completely behind the hull. You are no longer navigating a simple trajectory between two stars. You are floating within a silent repository where the universe stores its unresolved dimensions. The geometry has held firm, the physics have remained balanced, and the ship rests quietly in the deep, unmeasured dark of the cosmos. The known grid of home is gone. The true journey has just begun, the architecture of absolute silence. Nothing outside the viewports indicates a traditional mechanical barrier, yet the universe has coordinates where kinetic energy seems to drop into complete suspension. Outside the glass, the glowing networks of the traversable corridor fade out entirely, replaced by a wide expanse where local measurements of matter drop to near zero. The instrumentation arrays, register in environments so sparse that the boundary between the physical hull and the surrounding space becomes mathematically irrelevant. Entering this specific pocket of space-time exposes a traveler to a configuration designed not to manipulate mass or curve light fields, but to preserve an environment of absolute acoustic isolation. To analyze this state of structural neutrality requires examining the underlying physics of acoustic propagation in a vacuum. On Earth, sound functions as a mechanical wave, a vibration that travels through the compression and rarefaction of a physical medium, such as air or water. When an object vibrates, it pushes against neighboring molecules, transferring energy in a continuous chain reaction that eventually reaches the human auditory system. Within the intergalactic medium and the deeper interior channels of this shortcut, the spatial grid contains fewer than a few hydrogen atoms per cubic meter. Without a dense distribution of molecular matter to collide and transfer kinetic energy, mechanical compression waves cannot form. The universe outside your hull is incapable of carrying a whisper, an engine roar, or a structural tear. Observing this void from the flight deck forces a shift in how a human observer perceives internal mechanics. The only auditory inputs available are those generated within the enclosed life cycle of the starship itself. The soft, rhythmic hum of the life support pumps, the subtle metallic clicking of cooling vents, and the slow circulation of oxygen lines are the only acoustic signatures remaining in the universe. These internal noises undergo a biological transformation when external inputs vanish. The human auditory system is naturally calibrated to filter out constant background noise when surrounded by everyday planetary soundscapes. However, when placed in an environment where external acoustic input drops to absolute zero, the brain's internal amplification increases. Physiological studies demonstrate that in rooms engineered to mimic this complete sensory isolation, human subjects begin to hear the internal mechanics of their own bodies. The low-frequency thumping of the heartbeat, the high-pitched whistle of the nervous system, and the fluid movement within the inner ear become distinct auditory events. You are not listening to the cosmos. You are listening to the biological machinery of your own life, amplified by the total absence of a cosmic medium. The drift of the ship remains entirely unpowered, maintaining a smooth trajectory that generates zero thermal friction or acoustic drag against the sparse outer field. The absence of local particulate matter alters your visual tracking arrays as well. In a standard planetary atmosphere, light scatters across dust particles, water droplets, and gas molecules, creating illumination fields. Within this absolute vacuum, light behaves with unhindered geometric precision. Rays of starlight cross the emptiness without refraction, appearing as clean, intense points against the dark. Galaxies situated millions of light years beyond the exit mouth do not appear as blurred clouds, but as pristine, sharp structures, their intricate spiral arms and interlocking star fields mapped out with total clarity across the deep. Yet, this space is not completely empty, and the silence is not a total void. Modern quantum field theory indicates that a perfect vacuum does not exist in our universe. If you were to sweep away every single atom, shield the region from every passing cosmic ray, and cool the coordinates down to absolute zero, the empty space would still possess a fundamental architecture. Operating at this baseline level is the cosmic microwave background, the faint, uniform afterglow of the Big Bang. This relic radiation fills every cubic centimeter of space, a cold sea of photons left over from the birth of the continuum, chilled by the expansion of the universe to a temperature just 7 degrees above absolute zero. If your ship's sensors are tuned to the microwave spectrum, the ink-black view outside the window transforms into a uniform, glowing field of ancient energy. This radiation is the oldest light in existence, traveling across the cosmos for over 13 billion years. carrying the imprint of the primordial universe before stars or galaxies had formed. Alongside this ancient light field, the vacuum is alive with sub-vacuum energy fluctuations. Quantum field equations show that the empty grid is constantly brewing with activity, where virtual particle pairs spontaneously materialize out of nothingness, interact for a fraction of a millisecond, and instantly annihilate one another. The architecture of absolute silence is, in reality, a stage for a continuous, subatomic dance of matter and energy that never rests. The ship passes deeper into the core of this neutral expanse, the pale visual highlights of the cosmic background fading back into a steady, uniform shade of black. The spatial indicators register no kinetic shifts, no gravitational acceleration, and no structural strain. Navigating through this highly sparse intergalactic medium allows the mechanical components of the craft to achieve total thermal and kinetic equilibrium. The heavy stress profiles generated by the preceding zones drop into insignificance, providing a necessary operational buffer before the vessel interacts with the next severe geometry. The environment remains perfectly balanced, the complete neutrality of the space acting as a protective envelope around the vessel. Without external landmarks to calculate or visual shifts to track, the human perception of velocity dissolves entirely. The ship does not feel like it is traveling across a cosmic highway. It feels suspended inside a massive, silent repository where the universe stores its unresolved coordinates. For the first time since entering the shortcut, nothing demanded your attention. The universe had stopped asking questions. It simply allowed you to exist within it, black holes and wormholes. The absolute stillness of the neutral vault slowly shifts as the local layout of space begins to contract. Outside the viewport, the uniform dark vacuum drops behind the vessel, replaced by a massive expanse of intense gravitational activity. The coordinates ahead are no longer empty. They are dominated by the most extreme configurations of mass permitted by the laws of nature. You are approaching the interface where black holes and hypothetical wormholes intersect. To comprehend the relationship between these entities, the evolution of a massive star must be examined. A black hole forms when a stellar core, containing several times the mass of our Sun, runs out of nuclear fuel. For millions of years, the outward radiative pressure generated by thermonuclear fusion balances the inward crush of the star's own gravity. The moment that energy is spent, the outward pressure drops to zero. The core undergoes an immediate collapse, packing the entire mass into a region where current equations predict a singularity, a boundary signaling that general relativity is no longer sufficient on its own and must eventually yield to quantum gravity. Surrounding this point of collapse lies the event horizon. The horizon is not a physical shell or a solid surface. It is a purely mathematical boundary in space. Once an object slips past this perimeter, the escape velocity required to break free and return to the outer universe exceeds the speed of light. Because no signal can travel faster than light, any matter, radiation, or information that crosses this threshold is permanently cut off from the observable cosmos. The vessel drifts along a calculated path, positioned safely outside this boundary line. Looking down from the flight deck, the visual landscape is clear. You are observing a sphere of absolute darkness, silhouetted against a swirling, highly luminous disk of superheated gas and plasma known as the accretion disk. This disk spins at relativistic speeds. Friction and magnetic forces heat the matter until it radiates intense X-rays and visible light, creating a bright, glowing frame around the central shadow. Within the classical framework of a static, non-rotating black hole, the internal path terminates at a point singularity, where matter is simply crushed out of its familiar form. Shifting the calculations to incorporate rotation, however, alters the internal landscape of gravity. Because real stars spin, the resulting objects possess angular momentum, a state defined as a Kerr black hole. This rotation twists the very fabric of space around the horizon, a phenomenon known as frame dragging. Rather than compressing matter into a single point, some mathematical solutions indicate that the internal singularity might take the shape of a ring. Because the math projects a ring rather than a solid point, specific pathways through the interior gravity fields emerge in highly idealized solutions. Certain equations suggest that an entering object could theoretically pass directly through the empty center of this ring singularity, avoiding the destructive forces of the infinite mass. However, contemporary physics treats this trajectory with heavy skepticism. Most theoretical physicists point out that the inner horizon of a spinning black hole is highly unstable, prone to an energy buildup known as mass inflation, which would likely destroy any physical bridge before an object could cross. If a spinning black hole represents a massive cosmic intake, the equations of general relativity permit another purely theoretical solution at the opposite end of the spectrum: a white hole. A white hole operates as the exact mathematical inversion of a black hole. While a black hole can only pull matter inward, a white hole is a hypothetical region of space-time into which nothing can ever enter, but from which matter and radiation are continuously expelled like a cosmic fountain. It is vital to distinguish between mathematical permission and observed reality. Physics has detected no observational evidence for white holes, and a spinning black hole does not automatically create a link to one. In high-level physics, the idea that a black hole and a white hole could join to form a traversable wormhole remains a highly speculative hypothesis, requiring specific conditions that nature may never actually realize. Even the massive black holes we observe are not completely permanent. Over immense stretches of eons, they are predicted to slowly lose mass through a subatomic mechanism known as Hawking radiation. Near the event horizon, quantum vacuum fluctuations constantly produce pairs of virtual particles. Occasionally, one particle drops past the horizon, while its partner escapes into space as real radiation. This slow leakage causes the black hole to gradually lose energy over trillions of years. Though the exact nature of its final evaporation phase remains one of the greatest unresolved mysteries in modern physics. The ship maintains its stable positioning, the specialized layout of the channel keeping the hull perfectly clear of the event horizon's pull. The visual interaction between the glowing accretion disk and the deep void outside provides a vivid demonstration of mass-manipulating space on the grandest scale. The physics remain extreme, but the local path remains secure, keeping the vessel suspended outside the active field of the dark sphere. The massive gravitational field begins to ease its grip as the ship moves past the outer perimeter of the spinning system, returning to a wide, uniform channel. The bright light of the accretion disk recedes into a quiet glare. The structural variables of the black hole drop behind the vessel, leaving the craft intact, stable, and drifting smoothly forward through the dark. Journey through a wormhole. The harsh, mechanical glare of the accretion disk fades into a distant ember, allowing the cabin indicators to slide back into a soft, restful dim. The heavy gravitational pull of the spinning star field completely releases your vessel. Ahead, the dark canvas of space begins to curve once more, but it carries no violent compression or destructive instabilities. What follows is a direct visualization of one of the most widely discussed theoretical models for a traversable spatial passage, a journey built out of pure geometry, operating at the absolute limits of contemporary physics. To experience a transit through this localized spatial distortion requires adjusting your visual expectations. In classical science fiction, these gateways are frequently depicted as chaotic whirlpools or flat sheets of dark violet energy. However, Mathematical frameworks established by general relativity indicate that a three-dimensional shortcut that warps space evenly from all directions manifests as a remarkably stable sphere. Suspended effortlessly against the stellar background, the mouth of the wormhole appears as a massive bubble of liquid light. The boundary possesses no physical surface, no metallic frame, and no solid threshold. It is a pure geometric transition zone. As the ship approaches the horizon of the bubble, the view out of the center window creates a profound visual anomaly. The outer rim of the sphere bends the light of our own galaxy into a concentrated halo of distorted starlight wrapping around the parameter, a consequence of extreme gravitational lensing. Yet, the interior of the sphere does not reflect your ship or the surrounding stars. Instead, the bubble acts as a clear, real-time lens displaying a completely distant sky. Through the center of the sphere, you can see a dense, glowing field of sapphire stars and delicate gold nebula clouds that belong to a galaxy situated deep within the unmapped sectors of outer space. The thrusters execute a sequence of short, soundless alignments, guiding the nose of the vessel directly toward the mathematical center of the sphere. The pace is slow, deliberate, and entirely free of vibration. Crossing the threshold occurs without a single jolt or mechanical warning. The boundary line simply slides past the hull. As the ship slips over the horizon, a subtle, profound shift sweeps across the navigation array. For a brief instant, every familiar constellation disappears from the sky, dissolving the geometric reference points that have guided human exploration for centuries. The universe behind you closes like a silent curtain. The stars of the home galaxy compressing into a single, diminishing point of light before vanishing from view. You have entered the central throat of the conduit. Inside this architecture, the sensation of velocity disappears, replaced by a feeling of heavy, absolute suspension. The vessel behaves as though it is floating down a long, slow-moving river at midnight, completely isolated from the traditional coordinates of distance. The walls of the throat are made of nothing but space-time itself, rippling with soft, cascading, shifting lights. Deep ambers, soft violets, and low-frequency indigos wash smoothly across the outer skin of the craft, representing external starlight heavily distorted by the curved geometry of the corridor. The internal systems operate in an estate of total equilibrium. The ticking signature of the cabin clock remains steady, yet its relationship to the outer universe has been entirely suspended. In this interior channel, the intense radiation hazards and the destructive caving forces we analyzed in previous chapters are held at bay by the localized negative energy regions predicted by theoretical models. The environment is remarkably stable, providing a serene, stable conduit through the bedrock of the cosmos. As the vessel drifts further down the central axis of the throat, the long columns of rippling color begin to expand, widening out into a spacious chamber. The pale, flowing light fields gently part, revealing a warm, expanding illumination directly ahead. The secondary mouth of the wormhole configuration is approaching. With a final, elegant glide, the ship crosses the secondary horizon and emerges into open space. The vacuum of the new galaxy welcomes the craft with a completely unfamiliar configuration of stars. Below the viewport, an immense emerald-colored nebula stretches out across the void, painting the darkness with silent strokes of dust and gas, while clusters of young, brilliant blue suns illuminate the night. The successful transit confirms the underlying assumptions of this theoretical voyage, bypassing the immense gulf of the intergalactic ocean in the span of a few quiet minutes, leaving the physical structure of your ship and the health of the crew perfectly intact. The ship settles into a stable drift within this new sector of the cosmos, its instruments mapping coordinates that have never been recorded by human astronomy. The visual transition from the home world to this alien expanse provides a vivid demonstration of mass manipulating space on the grandest scale. The spatial crossing is complete. The exotic architecture of the throat drops completely behind the hull, locking its secrets back into the geometry of the dark. The vessel floats quietly in the calm, unmeasured vacuum of a new sky, time travel and paradoxes. A single timestamp flashes on the secondary navigation console. It displays a sector reading and a specific calendar matrix belonging to a moment your vessel has not yet reached. The pristine drift within the unmeasured vacuum remains calm, but the internal layout of the voyage is entering a far more unsettling layer. You are no longer merely mapping coordinates across the physical landscape of the universe. By traversing a path whose entrances are anchored in opposing gravitational sectors, the craft has systematically uncoupled its tracking systems from the linear progression of the cosmos. The spatial corridor is clear, but the temporal link introduces mechanics that challenge the core relation of cause and effect. You are entering the zone where time travel and its deep logical limits intersect. To analyze the possibility of navigating backward through the timeline requires examining a specific geometric solution within general relativity known as a closed time-like curve. In flat regions of space, time behaves like a rigid, one-way system, forcing every physical entity to move forward from yesterday into tomorrow at a uniform pace. However, because field equations dictate that mass and energy curve space-time, extreme fields can warp the grid so severely that the timeline itself bends into a loop. If an advanced engineering framework were to manipulate the 2 mouths of a traversable wormhole, a temporal loop could be deliberately constructed. Imagine keeping the primary entrance stationary in flat space while accelerating the secondary mouth to near light speed, or positioning it deep within the intense gravity well of a spinning stellar remnant. As established in our exploration of time dilation, the clock at the accelerated mouth would advance at a significantly slower rate. Over long eons, a permanent chronological gap opens between the 2 entrances. Under this specific configuration, a traveler entering the accelerated mouth would not merely exit in a distant sector of space, they could emerge from the stationary mouth at a date on the calendar that predates their departure. The shortcut through space has successfully transformed into a shortcut through duration, creating a physical pathway that loops backward into the past. The navigation display briefly shows 2 conflicting timestamps, blinking silently against the dark instrumentation panel before quietly resolving into a single, steady metric. The ship holds its quiet glide through the dark expanse, the mechanical sensors showing 0 vibration. Yet the conceptual foundations of the journey continue to expand. Navigating a loop in the timeline brings a vessel face to face with a classic logical contradiction, the grandfather paradox. This paradox represents a fundamental logical wall. Imagine a traveler who utilizes a closed, time-like curve to journey backward by several decades. While operating within those past variables, the traveler takes an action that inadvertently prevents their own grandfather from ever meeting their grandmother. The consequence of this disruption cascades forward through the timeline. If the grandparents never meet, the traveler's parents are never born, meaning the traveler themselves can never come into physical existence. Herein lies the structural contradiction that breaks the logic of the continuum. If the traveler does not exist, they could never have boarded the starship, entered the wormhole throat, or traveled back in time to cause the disruption in the first place. If they did not cause the disruption, their grandparents meet normally, leading to the traveler's birth, which allows them to journey backward and cause the disruption after all. The timeline locks into an infinite, self-canceling cycle of cause and effect, a failure of logical consistency that the laws of nature cannot naturally accommodate. To resolve this gridlock, without abandoning the mathematical permission of general relativity, Theoretical physicists rely on two primary competing frameworks. The first approach is the Novikov self-consistency principle. Developed by Russian physicist Igor Novikov, this principle dictates that space-time is fundamentally a single, unyielding, four-dimensional fabric that cannot be rewritten. Under this rule, the laws of physics will strictly forbid any action that creates a logical contradiction. If you travel into the past, your presence and your actions are already a historical fact. They have always been a part of the baseline timeline. If you attempt to alter a historical event, you will find that the universe enforces consistency through pure physical constraints. Perhaps the mechanism you use malfunctions, or your actions inadvertently cause the exact historical outcome you were trying to prevent. The timeline remains continuous, allowing backward time travel to occur while completely locking the door to any causal disruption. The ship passes a faint, shimmering boundary where the light fields outside appear to flatten out, stabilizing into a uniform state of deep stillness. A second, more radical solution introduces the quantum mechanical framework known as the many worlds interpretation. Under this model, the universe handles a temporal loop, not by altering a single timeline, but through the mechanics of quantum branching. When a traveler emerges from the secondary mouth of the wormhole in the past, their arrival is interpreted as occurring within a different branch of reality, rather than stepping into the history books of their origin universe. Instead of changing a single thread, the arrival aligns with a divergence, connecting to a separate, parallel branch of reality. In this separate universe, the traveler can disrupt the lineage or alter historical events without creating a logical paradox. They can prevent their birth in this secondary universe, because their origin remains secure in the original branch from which they departed. Yet, this solution introduces a profound sense of isolation. The traveler can never return to the specific future they left behind. Every attempt to navigate backward or forward merely weaves them into a separate web of parallel histories, permanently separating them from the coordinates of their home. Modern physics treats these temporal loops with intense skepticism. In the late 20th century, physicist Stephen Hawking proposed the chronology protection conjecture, suggesting that nature possesses an inherent mechanism designed to lock the door against time travel before a paradox can even form. Hawking argued that the moment a closed time-like curve begins to stabilize, the vacuum fluctuations of quantum fields inside the throat would loop back on themselves infinitely, creating a catastrophic buildup of energy similar to the audio feedback generated when a microphone is placed too close to a speaker. This runaway energy surge could instantly destroy the throat, snapping the loop before any physical object could pass through. The ship holds its steady drift within the silent vacuum, leaving the theoretical loops and the intense debates of quantum mechanics behind. The metrics confirm that your local framework has remained fully intact, protected by the remarkably stable geometry of the conduit. The laws of logic have not broken, the timeline has not fractured, and the hull remains surrounded by an unmoving, peaceful dark. The universe has ceased its heavy manipulation of duration, returning your vessel to a quiet state of simple, unadorned existence. You are floating within a calm, neutral sky where the calendar no longer demands an answer, advanced civilizations, and the future. The navigation terminals have gone dark, clearing the flickering metrics of timelines and gravitational fields from the display. Outside the viewport, the alien stars of the new galaxy hang like suspended shards of glass in a deep, velvet vault. The intense technical friction of the crossing, the radiation wells, the structural caving pressures, and the logical limits of temporal loops has settled into a distant historical memory. The ship rests in a state of unpowered equilibrium, floating at the edge of an immense cosmic sector that holds the final architectural question of the journey. You are observing the ultimate boundary where physics meets engineering, legacy of advanced civilizations and the ultimate horizon of space-time engineering. To analyze how physical intelligence could construct or maintain a traversable shortcut across space requires stepping onto the upper tiers of technological scaling. In 1964, Soviet astronomer Nikolai Kardashev formulated a method for classifying civilizations based on the total scale of energy they could capture and manipulate. A Type 1 civilization is characterized by its capacity to utilize the entire energy budget of its home planet, managing its atmospheric, geological, and radiative resources cleanly. Humanity currently occupies a transitional state below this metric, operating on the fractional scale of a single global biosphere. Constructing a stable, macroscopic wormhole like the one your vessel has navigated demands scaling far past these elementary levels. A Type 2 civilization possesses the capacity to harvest the entire energy output of its local star, utilizing advanced engineering concepts like a Dyson sphere, a theoretical swarm of megastructures designed to intercept and redirect the total radiant energy of a sun. Yet, even a stellar energy budget falls short when confronted with the task of expanding a subatomic tier in space-time. Propping open a stable conduit large enough to accommodate a physical vessel requires moving into the domain of a Type 3 civilization. An intelligence capable of manipulating the energy resources of an entire galaxy, tapping into the power output of billions of star systems, active galactic nuclei, and supermassive black holes. The hull remains perfectly silent, its external sensors registering a faint, low-frequency ripple moving through the background vacuum. The distortion carries no immediate physical hazard. It functions as a faint, lingering echo of structural stabilization, indicating that the gateway you crossed is not a natural anomaly, but an engineered artifact. Holding such an artifact open against the natural inward collapse of general relativity requires continuous technological maintenance at the grandest scale. Theoretical physics suggests that an engineering intelligence operating at this level would not merely search the cosmos for naturally occurring wormholes, they would actively cultivate them out of the subatomic foam. Using ultra-high energy particle colliders or localized concentrations of negative energy fields, a Type 3 framework could theoretically target a quantum fluctuation at the Planck scale, isolate it from the surrounding vacuum, and inflate it into macroscopic dimensions. Once inflated, the primary challenge transitions from creation to permanent containment. The engineering requires stabilizing the mouth against the continuous degradation caused by mass inflation and external particle influx. Theoretical design suggests lining the interior throat with thin, highly dynamic layers of exotic matter, managing the distribution of negative energy density with absolute precision to match the mass of entering objects in real time. The gateway becomes a responsive, automated system, balancing its own fields dynamically as matter crosses its horizon, neutralizing the trigger problem before a structural cave-in can begin. The ship executes a slow, passive rotation, bringing a magnificent visual structure into the center of the view deck. You are looking toward the terminal boundary of the new galaxy, where the interstellar gas lanes begin to thin out into the intergalactic void. The vast darkness beyond is no longer an insurmountable barrier, but an open ledger of potential trajectories. Navigating this interconnected grid alters the long-term survival horizon of intelligence itself. The universe is governed by the unyielding laws of thermodynamics, moving slowly but inevitably toward a state of total energy exhaustion known as the heat death. Over trillions of years, stars will burn through their hydrogen reserves, fading from brilliant blue suns into cold, dense remnants. Galaxies will drift too far apart for light to cross the intervening space, isolating stellar systems in a permanently cooling dark. Under a standard, non-connected model of the cosmos, any civilization locked within a single galaxy faces an absolute expiration date. However, if traversable wormholes can be permanently stabilized, the the geography of survival expands. An advanced intelligence would possess the structural pathways to evacuate dying sectors of the universe, transferring resources, populations, and energy grids across vast intergalactic distances to younger, active sectors where star formation still thrives. The shortcut through space ceases to be a simple navigational convenience. It becomes a fundamental evolutionary mechanism, allowing life to outmaneuver the chronological decay of its host galaxy. The external array slowly shut down, entering a baseline standby state that mirrors the absolute neutrality of the quiet sky outside. The visual remnants of the shortcut fade into the dark background, leaving the craft suspended in a pristine, unmeasured interval. The theoretical blueprints have been executed. The limits of mass and geometry have been balanced, and the vessel floats safely within a universe that has quietly redrawn its borders. For the first time since the journey began, the tracking monitors show no new destinations, no upcoming structural changes, and no oncoming gravitational drops. The cosmic vault has closed its heavy parameters behind you, leaving the hull surrounded by an unmoving, peaceful dark. The variables of space and time have found their long-sought rest, allowing your vessel to exist quietly within the silent, infinite chambers of a permanent home. The quantum gravity puzzle. The pristine, unmeasured drift within the vast vacuum of the new galaxy leaves your vessel operating in a state of absolute kinetic suspension. Yet the underlying foundation of the journey remains incomplete. You have traveled across vast intergalactic distances. Stabilization fields have balanced the immense gravitational stresses, and the local clocks have mapped the elastic changes in duration. Yet, at the core of every single calculation used to chart this course lies a profound cosmic division. The theoretical physics that permitted this crossing are split down the center, revealing a structural fracture in humanity's understanding of the cosmos. You're approaching the ultimate boundary of modern science, the search for quantum gravity. To comprehend why this puzzle remains unresolved, the two pillars of contemporary physics must be viewed as inherently adversarial frameworks. The first pillar is Albert Einstein's general relativity, the geometric theory of gravity. General relativity treats space-time as a smooth, continuous fabric that warps, stretches, and curves under the influence of massive bodies like stars and black holes. It is a highly deterministic architecture that operates flawlessly on the macroscopic scale of the cosmos, providing the exact mathematical maps used to project the layout of wormholes and gravitational wells. The second pillar is quantum mechanics, the framework that governs the subatomic scale. Quantum mechanics views the universe not as a smooth fabric, but as a chaotic, probabilistic arena filled with discrete packets of energy and volatile fields. On this scale, particles do not possess fixed positions or predictable trajectories. Instead, they exist in states of superposition, their behavior governed by probabilities until an interaction occurs. When physicists attempt to merge these two frameworks to analyze the extreme physics inside a wormhole throat or a black hole singularity, the mathematics immediately break down. Applying the smooth, geometric equations of general relativity to the chaotic, energetic fluctuations of the subatomic scale yields nonsensical results, projecting infinite values for energy density and space-time curvature. The universe cannot function on infinities. The breakdown signals that a deeper, more fundamental theory, a unified architecture of quantum gravity, remains hidden from view. The starship continues its passive tracking through the sapphire suns of the new sector. The instrumentation displays operating in total stillness, yet the internal computers continue to struggle with this structural conflict. To bridge this divide, theoretical physicists have formulated highly ambitious frameworks, the most prominent of which is string theory. String theory proposes a radical rewrite of the fundamental building blocks of matter. Instead of treating subatomic particles like electrons and quarks as zero-dimensional points, this framework suggests they are actually tiny, vibrating loops of energy, strings. Just as different vibration frequencies on a cello string produce distinct musical notes, the varying vibrational signatures of these cosmic strings manifest as the different particles that make up the periodic table. Crucially, string theory demands the existence of a specific particle called the graviton, a quantum carrier of the gravitational force, which emerges naturally from the mathematics of a vibrating string loop. However, implementing the equations of string theory requires a massive departure from our perceived reality. The mathematics only function consistently if the universe contains extra, hidden dimensions of space. Instead of the three familiar dimensions of height, width, and depth, string theory projects a continuum containing 10, 11, or even 26 dimensions. These extra spatial dimensions are tightly rolled up or compactified, at scales smaller than a single atom, remaining completely invisible to human senses and macro instruments, yet shaping the fundamental laws that govern the stability of shortcuts through space. As the vessel drifts further through the calm vacuum, a separate, equally staggering quantum connection begins to register on the deep tracking arrays. In 2013, physicists Juan Maldacena and Leonard Susskind proposed a profound theoretical identity known as ER-EPR, EPR Malus. This equation links two seemingly unrelated concepts discovered by Einstein: the Einstein-Rosen bridge, which is the mathematical description of a wormhole, and the Einstein-Podolsky-Rosen paradox, which describes quantum entanglement. Quantum entanglement occurs when two subatomic particles become deeply correlated, linking their physical states so precisely that an alteration to one particle instantaneously dictates the state of its partner, even if they are separated by the entire width of a galaxy. This immediate connection seems to violate the cosmic speed limit set by the speed of light. The ERET-EPRs. Conjecture suggests a beautiful geometric solution to this quantum mystery. The hypothesis states that entangled particles are not communicating across flat space through some impossible, faster-than-light signal. Rather, the two entangled particles are physically connected by a microscopic, non-traversable wormhole operating at the Planck scale. Quantum entanglement, the very fabric of subatomic connectivity, may simply be the microscopic manifestation of spatial wormholes woven through the quantum vacuum. The grand architecture that allows your starship to cross intergalactic distances could be nothing more than a macro-scale inflation of the same fundamental bridges that link every atom in the cosmos. The ship enters a sector where the background radiation stabilizes into a remarkably uniform field. The instrumentation panels dropping their technical alert grids as the local calculations find a temporary equilibrium. The structural variables of the quantum vacuum remain active at the micro scale, but the macroscopic path remains undisturbed, holding your craft safely within the peaceful dark. The complete resolution of this puzzle remains locked away from modern science, an open horizon that requires an intelligence capable of reconciling the smooth geometry of the cosmos with the chaotic dance of the subatomic scale. The ship holds its course, moving silently past the unresolved questions of the continuum, leaving the mathematical fractures behind as it drifts toward the absolute terminal boundary of the journey, the ultimate horizon. The final configuration matrices on the instrumentation console slowly step down, systematically extinguishing the remaining grid lines until only a clean, dark interface remains. Outside the viewports, the unknown configurations of the alien stars recede into a quiet baseline, settling into a uniform backdrop. The severe variables that have governed this voyage, the intense mechanics of spatial tearing, the stabilizing dynamics of exotic matter fields, the elastic variations of duration, and the complex mechanics of quantum loops, have completely receded from the tracking systems. The vessel has completed its kinetic obligations, settling into a passive drift at the edge of space-time navigation. You are resting at the ultimate horizon, where the physical layout of the universe gives way to a quiet reflection. To look back across the path of this theoretical voyage is to realize that the cosmos is far less isolated than humanity once believed. In the early eras of terrestrial exploration, the vast intergalactic ocean was viewed as an absolute barrier, a crushing, infinite void that isolated conscious life within the fragile boundary of a single planetary biosphere. The staggering distances between stars meant that any voyage beyond the solar system would require generations of isolation, rendering the wider universe permanently out of reach. If the geometries we have modeled throughout this journey could ever be realized, that ancient isolation dissolves. By understanding that the fabric of space-time can be curved, stabilized, and crossed, the universe ceases to be an unyielding collection of isolated points. It transforms instead into a beautifully integrated canvas where the farthest margins of the cosmos are brought within imaginable reach. The hypothetical architecture of the shortcut bridges the impossible gulfs between separate galaxies, allowing conscious intelligence to transcend its localized origins and step into a wider role within the cosmic story. The starship continues its soundless, unpowered drift through the velvety dark of the boundary zone, its external sensors registering zero friction, zero gravitational gradients, and zero thermal variations. The environment has reached a state of deep, unyielding equilibrium. This vast stillness brings a human traveler face to face with the final weight of the voyage. The journey was never merely about overcoming the immense limits of propulsion or tracking metrics across a grid. It was an exercise in scientific humility. Every equation passed, from the classical curvature of general relativity to the volatile fluctuations of the quantum vacuum, has highlighted just how much of the cosmos remains beautifully unresolved. We have pushed our models to the very edge of the singularity, only to find that the universe always keeps its deepest secrets closely guarded. Yet, that uncertainty is not a failure. It is the fuel of human wonder. The realization that space and time are elastic coordinates capable of being woven together by the laws of nature changes our position in the dark forever. We are no longer passive observers trapped on a lone shore, looking out at an inaccessible ocean of light. Even in our theoretical calculations, we have become navigators, tracing the delicate, invisible threads that bind the birth of a star to the structure of a subatomic particle. As the vessel drifts further toward the quiet edge of the unmeasured void, the remaining external sensors quietly go offline, one by one. The bright visual tracking lines that once mapped the path through the throat have completely dissolved, leaving the hull enveloped in a pristine state of dark suspension. The technical debates of quantum gravity, the highly speculative mathematics of parallel histories, and the immense engineering demands of advanced civilizations no longer require answers. The voyage has reached its natural conclusion. The calculations have been balanced, the geometry remains stable, and the ship rests quietly within a universe that has laid down its barriers. The known coordinates of the origin world have faded into the permanent layout of the background cosmos. For the final time, the internal display terminals clear their metrics, fading smoothly into complete darkness. The universe has stopped demanding speed, duration, or direction. It simply allows your vessel to exist quietly within the silent, infinite chambers of a new home. The journey is complete. The dark is at peace.